Hello students, welcome to our second lesson in Senior Secondary 2 Physics. Today, we'll dive into the concept of speed, velocity, and acceleration. But before moving ahead, let's take a moment to revisit what we covered in the last lesson. In our last lesson, we explored position, distance, and displacement. We also discussed the differences between position, distance, and displacement. We further went ahead to solve some calculations using examples. Exciting, isn't it? Before we dive in, let's look at our lesson objectives. By the end of today's lesson, you will be able to understand the difference between speed, velocity, and acceleration. Identify that speed is a scalar quantity, while velocity and acceleration are vectors. Calculate the resultant velocity using examples where an object changes direction. Are you ready? Sit tight, let's dive in. Firstly, speed. Speed is the distance an object travels per unit of time. It is a scalar quantity, which means it has no direction, just magnitude. Speed is calculated using the formula. Speed equals distance divided by time. It tells us how fast an object is moving. But it doesn't tell us anything about the direction. For example, if a car travels 100 kilometers in 2 hours, we just know its speed is 50 kilometers per hour. It's a scalar quantity, which means it has no direction, just magnitude. Now, velocity. Velocity is a vector quantity, meaning it has both magnitude and direction. Velocity is a bit more specific than speed, because it tells us how fast something is moving, and in which direction. We find velocity using the formula. Velocity equals displacement divided by time. For example, a plane moves 100 meters north in 20 seconds. Let's solve this using the formula. Velocity equals 100 meters, which is the displacement, divided by the time, 20 seconds. Which gives us 5 meters per second. It's easy. Let's find out about acceleration. Acceleration tells us how quickly an object's velocity is changing. Just like velocity, acceleration is a vector quantity, so it also has magnitude and direction. To find acceleration, we divide the change in velocity by the time taken, where the symbol represents the change in velocity. For example, a car speeds up from 0 to 20 meters per second in 4 seconds. What is the acceleration? From the question, the change in velocity is 20 meters divided by the time taken, 4 seconds. That gives us 5 meters per second squared. Let's move on to discuss resultant velocity. Next is resultant velocity. A resultant velocity is the combined effect of two velocities acting in different directions. See how it works. If an object is moving in two different directions, that's when we need to calculate the resultant velocity. Example. Let's say a boat is moving 4 meters per second east and 3 meters per second north. To find the resultant velocity, we combine these two directions. Using the Pythagorean theorem, we find the magnitude of the resultant velocity. Follow me. Let's break this down. The Pythagorean theorem states that a square plus b square equals c square. Solving this, we will use the formula. Hypotenuse square equals to base square plus height square. For this problem, VR square equals 4 square plus 3 square. In this case, VR represents the resultant velocity of the object, example, the boat. Next we square the values of the base and height. VR square equals 16 plus 9. Then, add the results. VR square equals 25. Next we find the square root. Take the square root of 25 to find the magnitude of resultant velocity. VR equals square root of 25, which equals 5 meters per second. Well done, you are doing amazingly well. Next, let's find the direction. Now, use trigonometry to find the direction. Theta equals tan raised to power minus 1 equals 3 divided by 4, which gives us 36.87 degrees. Very simple. This is how we calculate the overall velocity when an object changes direction. You're making progress, keep it up. Now it's time for you to practice. Here's a quick practice problem. Ensure to pause the screen or write out the given task to solve the problem. Assignments help you gain a stronger understanding of a topic. Give it a shot. Good luck. Well done. Let's summarize what we've learned so far. Speed is a scalar and tells us how fast something is moving, but with no direction. Velocity is a vector and tells us both the speed and the direction of motion. Acceleration is also a vector and tells us how quickly velocity is changing. We also learned how to calculate resultant velocity when objects move in two directions, using the Pythagorean theorem and trigonometry. In our next lesson, we will be learning more about velocity time graphs, and also explore the differences between speed and velocity. Well done. You've come to the end of this lesson. Keep practicing what you've learned. I will see you in the next lesson.